So I'm going to start off with something a little bit different. Starting with your tables to be just great. Trigonometry is all about the angle. Ratio, sine, cos, don't get in a tangle. Area of a circle, pi r squared. Pi times 2r, circumference if you can. Y equals m over c is just a straight line. M the gradient, c the intercept we find. Numerator over denominator. Better get it right, or Mr. Seagull, see you later. Thank you. Thank you. So the story behind this is I was teaching a class of year 10 students in my maths GCSE class. And there was a student at the back of the class, and I won't say his name. He was sort of bobbing his head along, and I was like, why is he bobbing his head along? We're doing some work. And I turned up near him, sort of stood behind, as a teacher normally does, and I saw he had headphones on. And then normally the rules are headphones on, automatic detention. And I approached him, and then he said to me, Mr. Seagull, no, Mr. Seagull, I was actually listening to maths music. I didn't believe him. But he genuinely was. He was listening to music that was sort of useful to learn, I think, the trigonometric identities. So from there I said, okay, what I'll do is, if you put your headphones away, I will write some maths music. I can't sing, I can't rap even. Well, I'll write some raps for you to help learn certain topics. So now it's always been a little bit of a party trick of mine. Whenever we have a new topic, I always bring a rap into the class. So this student now will know that it's his fault he's inflicted the pain of Mr. Seagull rapping on lots of people. So, firstly, I wanted to say to all of you, thank you for coming here. So as it says there, mathematics needs you. So the fact that you're all here, listening to a talk about numbers, suggests that you probably have had a good relationship with numbers. But today I want to talk to you about some of my life experiences, how maths has shaped it, and also a bit about how I think in this country we can have a more positive relationship with mathematics. Before I start, I want to tell you a bit about myself. So, in the top left, we have a picture of me as a doctorate student. So some of you may recognize me from University Challenge, and I did that while I was at Emmanuel, Cambridge. So I'm still at Emmanuel in Cambridge researching maths anxiety. So this is when people, sort of, if you get that lumpy feeling in the back of your throat, your heart racing, sweaty face. With mathematics, people often get that. I mean, I find it strange, people don't get this when they open up a book to read or when they're doing history or art. But with mathematics, it tends to induce a really strange sort of fear. Even for people like myself, that I feel quite confident with numbers, sometimes someone asks me a question on the spot, I'll get a bit racy as well. So my research doctor is trying to understand why are people anxious about mathematics and what we can do ultimately to overcome it. And then the top right there is one of my favorite pictures as a teacher. So actually, I'll give a shout out to my students. Hello. So I used to teach at a school called East London Science School. I teach now at Little Ilford. But these are my students there, and so I'm also a part-time maths teacher. And the reason why I still teach is, one, I think being around young people is energizing, but partly also because if I'm trying to be out there, trying to become someone that really talks about mathematics and why I really love it, you need to really be next to the end consumer, the customers, and the students are the toughest customers. And if you can see them every week eye to eye and get them to like Pythagoras' theorem and trigonometry, then you know that perhaps you got some of the message there. And then the bottom left and right are what sort of I've been really fortunate in the last couple of years where, so you recognize that that's my pal, was once nemesis, as correctly pointed out, Mr. Eric Monkman from Canada. Eric Monkman. So he defeated me in University Challenge, but I forgave him. So on Monday, we had our first ever episode of Monkman and Seagull's Genius Guide to Britain. And essentially this is the two of us as friends going around looking at Britain, but traveling around exploring its scientific and technological past. And one of my personal favorite scenes is the bottom left. So there's a really tall tower called the Emily Moore Tower in Yorkshire. And I always used to think that the Shard at 324 meters was the tallest freestanding structure in the UK. But actually, we found out there was something else. And then Eric and I, we told our producers, can we please, can we use trigonometry on primetime TV? And the producer's like, it's never going to work. Trigonometry on primetime TV on BBC Two, it's not going to work. Maybe if you bake something trigonometry related, it might work, but not actual mathematics. So my friend and I, we did some basic GCSE trigonometry. So again, students in year 11 would have been able to work it out as well, just using the tangent. So I was really proud that we could use trigonometry on primetime TV. And the bottom right is, again, I feel really blessed because I love mathematics, and my students here will know that whenever I used to teach them, I used to always say, oh, maths is so important, you need to love maths. Maths is really relevant to everyday life. But I've had the chance now not just to talk to my students, but I've had a platform to talk to more people. And again, through the Financial Times, I sort of write articles about mathematics. I do my puzzles on Radio 4. Okay, but just to show that things are not always really good for me, I'm from East Ham, very proud of it, but I support a club called West Ham. They're not doing particularly well. But the reason I've got this slide up in particular is because, again, the book is called The Life-Changing Magic of Numbers, because it's about how maths has changed my life. And actually, my first love before mathematics was football. And I'll explain how football drew me into mathematics and numbers. So as a child, you know, in the playground, people used to buy stickers back then. Hands up whoever remembers stickers. You know, the small, stickers. So what we used to say was like, got need, got need. And when you had something that you needed, you got really excited. Like, oh, I need the sticker. But as students and children, as I think 8 or 9, we'd always say, oh, I think Ian Wright's better than Matt Letizia. Oh, I think West Ham are better than Arsenal. Not true. But all these are sort of just people making speculation assertions. And I found actually, I didn't really feel comfortable making assertions. So I thought, actually, what would be really good is if I can ground my opinions. So I did the really geeky thing for an 8 or 9-year-old. I took all the data in the Premier League sticker book, so players, age, height, goal scored, the left foot, right foot, headers, appearances, substitute appearances. I put it all into a big spreadsheet, and it formed my database. So whenever friends would come up and say in school, oh, Bobby, I think Matt Letizia is better than Ian Wright, I'd go back home, tap into my spreadsheet, Matt Letizia, Ian Wright, some sort of data stats, and I'd come back the next day to school and go, actually, Matt Letizia scored 10 goals, of which only 1 was a penalty, but Ian Wright scored 4 penalties, so he's not actually a better striker. So what I found was that numbers allowed me to give myself credibility as a 9-year-old in the school playground when people are saying, you know, sort of making speculations about different things. Numbers gave me the confidence to actually express myself. And when people ask me, why do I love numbers? I'll tell you why. If you wake up in the morning and let's say your kettle's broken, you can't have a hot cup of tea, you get your cereal and it spills on yourself, and you go to work and the tube is late. So all these are sort of uncertainties of life. You know, that's the part of the beauty of life. It is uncertain. But mathematics, especially at school level and at most at university level, we've got that certainty. No matter what time of day that you've sort of woken up, no matter whether you've been arguing with your siblings, 7 times 7 will always be 49. And that's really reassuring to me. So, one of the things I've done this year is the BBC have decided they wanted to put a spotlight on mathematics, because we all know that conversation. If you go into a pub or you meet friends for dinner and someone mentions that they're a maths teacher or a mathematician, the sort of reaction's like, oh God, he does maths. Let's walk away from him. And if not, people often put their hand up and say, I couldn't do maths. And you'll see lots of other people saying, oh, I couldn't do maths. I couldn't do maths. And I think maths is quite unique in that way, in which people sort of have a badge of honor if they can't do maths, particularly in this country. So the BBC said, oh, let's do a series this year, a mini-series, trying to understand why this is, why people have a negative perception of mathematics. So part of this, what they did was 3 of their presenters, hands up who recognize these BBC presenters here at all? So these are the BBC breakfast presenters. So you've got Naga, who's one of the main hosts in the middle. Then we've got Tim Moffat on the right, and then we've got Jane McGubbin. So these actually represent almost like all different types of learners. So Naga, so hands up who thinks at school they were sort of like, they were really always confident, always wanted to do maths. You better put your hand up, Harpal, come on. Yeah, he is good at maths, okay. Yeah, so Naga represents that. People like us who are like, they feel confident, they make a mistake in maths, they're like, oh, it's fine, I'll get better. So she was like the sort of the confident maths learner. Then at the other end, completely opposite, we've got Jane. And Jane, she's absolutely lovely, one of my favorite people I met. And yet she had a terrible experience in maths. I think she got a D or E first time round. She found numbers didn't really stick, and it just was like a really uncomfortable experience. Anyone here that found maths at school didn't quite work for them? Yeah, a few, well done for putting your hand up, yeah. And then in the middle we have Tim. Tim's like the rest of us. We're like, oh, I didn't really love maths, didn't really hate it, I just sort of deal with it. So the BBC picked these 3 people to represent that journey. Fortunately for me, all of them did pass, so Mr. Seagull wasn't publicly embarrassed on national TV, but it just brought out the debate about why maths needs to be sort of encouraged by all of us, and our attitudes towards it are particularly important. So one of the things that I always tell my students, so growth mindset and fixed mindset, it's something that's been a little bit discredited recently. So I do read academic papers, and there's some papers that say actually these two theories don't really work. But I'll still explain why it's important to me as a maths learner. So as a mathematician, when you come to a subject, if you're learning, let's say, Pythagoras for the first time, you may not understand it. So there's two responses you can have. You can have the fight or the flee. So you can either go, yes, I think I can try this, fine. I didn't understand it first time, but I'll keep trying harder. Or you can be the person that says, oh, I'm not really a numbers kind of guy. I should just give up on mathematics. I heard a really good analogy by an Australian mathematician called Eddie Wu. He's a really sort of popular math teacher there. And he said, when he was growing up, he couldn't see particularly well. So the response could have been, yeah, I'm not a seeing kind of guy, just not meant to see the world. Or you can get glasses. You can get corrections towards that. So the same thing with mathematics. You don't have to accept not being good at it. Fair enough, all of us are not going to do maths at university and win the Fields Medal, which is like the Nobel Prize for maths, but we can all feel more comfortable. We can all get to a situation when we look at numbers, we're not afraid of it. And that's why I think growth mindset, whether it's coming to driving, again, before I did the Monkman and Seagull driving the Genie's Guide to Britain, I couldn't drive. I drove a few times 7 years ago. I'm a terrible driver. Luckily, they edited to make me look as if I'm competent. But again, I had a growth mindset. I said, okay, I can't drive very well, but I'll learn. I'll have lessons. And I got better. I'm not a great driver. I'm not going to be invited to Top Gear anytime soon, but I feel competent in it. And I think with mathematics, the same thing. You might not be able to, smash an A-level paper or do well at university, but as long as you can do the things that make you feel comfortable on a day-to-day basis, then you've made progress. So I've got these three people up here, and often I do assemblies in my school about mathematics and why I think it's really cool. And I bring up this slide, and I often ask people, hands up, so in this audience, who recognize the person on the left here? Should be most of us, yeah? The person in the middle, a few more, maybe about the same, and the person on the right? Okay, only a few, so it's even less, yeah. So in my school, actually, it's even more stark. The first one is, I think, the best footballer right now. Some people would say Lionel Messi, but Cristiano Ronaldo, and recognized globally as like a hero in his field. Then in the middle, we've got Beyonce. And again, I've seen Beyonce once in a Twickenham concert, and she's so good at her craft that when she was singing, so 70,000 people in the stadium, I thought she was singing to me. I was like, she's looking at me. She is, she's talking to me. She's that good. And again, she wasn't born like that. She developed her craft, developed her trade, that growth mindset. But the person on the right is the one that I want to talk a little bit about, not too much, because I could do a whole talk on this. His name is Andrew Wiles. So when he was an 11 or 12-year-old boy, he saw Pythagoras' theorem. And Pythagoras' theorem that we should most of us remember, it's like a squared plus b squared equals c squared. Coming back, yeah, the right angle triangle. Well, there's an equivalent sort of that. It's x to the n plus y to the n equals z to the n. So proving that it doesn't work for anything where n is greater than 2. And this was set, I think, in 1637 by a mathematician called Pierre de Fermat. And he was a cheeky mathematician because in the side of his margin, he said, I sort of have a proof for this, but I can't be bothered to write it. So it sent mathematicians on a wild goose chase for 350 years. And it took Andrew Wiles to come and solve this. So for me, I'm a massive football fan, I love my pop music, but for me, he is an even bigger hero than Ronaldo or Beyonce. And I think as a society, we should start appreciating scientists and mathematicians more because these are the kind of role models that we want. Of course, there's always a place for the sort of glamorous people like Ronaldo and Beyonce, but we need to sort of, not idolize, but say, yeah, these are the people that we want to aspire to in society. So, lucky streak. So, I'd like to think I've maybe been lucky or not lucky. So I'll explain what these 4 pictures are. So on the top left, does anyone remember Supermarket Sweep? Supermarket Sweep with, I think, Dale Winton. So about when I was 27, so the age 3 cubed, 3 times 3 times 3, I won a competition in my local area to open up the pound shop. And as part of the deal was, I got to run around the shopping mall for 99 seconds and pick up lots of different items. I won that. Then on the top right, I once won a competition where I got to stay in the Atlas Mountains. Anyone ever been to the Atlas Mountains in Morocco? Absolutely stunning. And so you answered 2 of my questions, Andrew as well. So I went to see the Atlas Mountains, and again, that was the competition I won. Then the bottom left, late 90s, it looks a bit clunky now, but I won a Dell laptop in a competition. And in the bottom right, if you can look, can you see in the far left of the picture? That's Michael Flatley, Lord of the Dance. He does like an Irish dance. I can't really do it myself. And then there, on the left-hand side, there's me. So I'd want a competition to meet him on the red carpet. So the question is, am I lucky, or is there something else at play? So I think it's to do with the law of large numbers. It's really simple. The more you do something, the more likely you are to get lucky. So the trick was, when I was younger, I used to love entering competitions. So back then, before emails, kids, and Twitter, people actually had to send letters, postcards, and these are all competitions with postcards. And what I used to do is, I used to cut out cereal boxes, make them into postcards, so like cornflakes and Weetabix and Cocoa Pops, and send them off. But I used to send off like 10, 15 a day. Obviously, the postage was quite expensive. My dad got a bit annoyed. But because I entered lots and lots of competitions, the harder I tried, the luckier I get. I found I was quite lucky. So in each individual competition, I wasn't lucky, but because I did it over a long period of time and sort of repeated the effort, I got lucky. So I would say, this is why I always tell people, the harder you try, the luckier you get. And this is definitely a case for me. So now, in 2016, mathematically, some people would say, irrespective of your political views, a quite remarkable year. We had Brexit, which happened, and that was 5-to-1 odds at one stage. And then America, Trump, at one stage, he was as wide as 150-to-1 to win the election. And then we had probably the most remarkable mathematical occurrence that year. Leicester City, which gives hope for me as a West Ham fan, won the Premier League at 5,000-to-1. And if you had the foresight to put £1 on this at the beginning of the year, just £1, and again, you needed to get the right odds with the right bookies, you'd have earned yourself £4.5 million. So if you had got Brexit, Trump, and Leicester in 1 year. And again, this is the power of accumulation. As someone who's a sports fan, I occasionally bet on sports things, and this is just the power of an accumulator bet. And you look at this and you think, wow, that's a miracle. How did this possibly happen? But I'd like to say mathematics can sometimes offer us a prism to understand why things that look like miracles may happen. So, sometimes when people say, oh, that was a 1,000,000-to-1 shot, that was never going to happen. There's a mathematician called John Littlewood from Cambridge, and then in 1968, he came up with a theory that tried to explain mathematically why miracles may happen. So he defined miracles as things that happen in a 1 in a million shot. So he said, in an average day, we're awake and alert for 8 hours a day. And in the 8 hours, we sort of see or hear things once a second. So one, another event, another event. So if you do 8 hours, times it by 60 minutes, times it by 60 seconds, we get 28,800 different events that we're exposed to. So most of them will be completely mundane. Maybe the traffic light turning green, or maybe a cuckoo falling, or you might your milk dropping on the floor. So these are all mundane, sort of regular things. But over the course of just over a month, so let's say a month, 35 days, we have 1 million different things that happen to us. So if you're technically saying that something happened and that was a 1 in a million event, mathematically, all of us have 1,000,001 thing happen to us once a month. So when people say miracles never happen, actually, each and every one of us, we have a miracle once a month. And if you scale that up to the global population of nearly 7.6 billion people, just imagine the number of coincidences. And obviously, we already notice the things that sort of are remarkable. So how many times when we're driving, we have green lights, we sort of just ignore it, and we just say, expect it to be green. But when we get 2 red lights in a row, we're fuming like, oh, my luck is rotten today. 2 red lights in a row. Oh, my tube was late. And we get upset. But again, mathematics shows us that as humans, we ignore all the sort of mundane things, but only pick up the things which seem remarkable. Hence, the 1 in a million. So, hands up who watched the original first Millionaires, the original ones. The original ones? Okay. Hands up who saw the new one that came up? Yeah? So yeah, I used to watch the old ones, and I watched the new one, and I loved the return of the new one in particular, because with students, I found it was a great opportunity to talk about something related to Who Wants to Be a Millionaire. So in the game show, you try and win 1 million, but in mathematics, actually, I tell my students, if I can get the slide up, that you can win $1 million, not £1 million, through mathematics. And there's something called the Millennium Prize problems. So, in 1900 in Paris, they came up with a set of the most important mathematical, I guess, theorems or proofs to be cracked. And recently, in America, the Clay Maths Institute said, these are the 7 most important things in maths that we think need to be solved. And if you solve it and you get it accredited by other mathematicians, you win $1 million. And I know when I teach my students, if I tell them there's a really difficult piece of homework that if you get right, you get $1 million, they get really excited. Obviously, they don't realize these are particularly hard, but they get very, very excited. It's so much so that one of my class said to me, "Sir, can we just stop working for the rest of the year and work on these problems, all of us together, for the entire year, and then we'll split the money 30 ways?" Yeah, it didn't quite work that way. But so far, only one of them has been solved, and this is called the Poincare conjecture. And again, even though I did maths at university, I barely understand it, but it's about geometry, and this particular one is like, imagine you've got a rubber band on the top of a football, it's like a point, and if you move the rubber band in through the football, you see the rubber band gets bigger and bigger and bigger into the middle. So this is essentially describing the movement of that. So that's the only one that's been solved by a mathematician called Grigory Perelman. But the story behind this mathematician is pretty neat. So this guy here, when he solved the sort of theorem, journalists came to his door and knocked and said, Mr. Perelman, you've solved the $1 million prize. When do you want to pick up the money? He said to the journalist, "Do not disturb me. I am picking mushrooms." Yes, he said, "I am picking mushrooms," when someone offered him the $1 million for solving the Poincare conjecture. And for me, this shows sort of partly the beauty of mathematics, because obviously, maths, I do think, should have a function. It should help you progress in everyday life, whether you're budgeting or looking at your holiday or you're planning a route. Of course, maths needs to have that functional element. But there are mathematicians out there, and I completely encourage them. They love mathematics for its own sake. And Perelman thought, I love maths because it's beautiful. I don't need money. I don't need prizes. I don't need sort of glamorous accreditation to be lauded for my mathematics. I'm doing it for its own sake. So he's probably off there hiding. And I tell my students, if you find Perelman and you can agree to him to sign off the $1 million, do get it. I'm sure we could do something valuable with it. But the one I wanted to talk to you briefly was about something called the Riemann hypothesis. So the Riemann hypothesis is something to do with this. So so just for the school kids here, do any of the school kids recognize what the numbers in yellow are? Go on, Harpo? Prime numbers, yeah. Thank you, the prime numbers. So I'll explain that in a second. So Bernhard Riemann, a German mathematician, he came with a theorem in 1859. And if this is a university challenge question and the answer is 1859, I would say, what year connects the year that the first pencil with a rubber was formed, the year that Darwin published his theory of evolution, and the year that Bernhard Riemann published his Riemann hypothesis? Buzz, Emmanuel Seagull, 1859. So 1859 was a remarkable year for those three things. I personally think the pencil with the rubber is pretty neat. So that, for me, is like the top achievement that year. But Bernhard Riemann essentially said prime numbers. So prime numbers are numbers with two factors, itself and 1. So for example, 7 can only be formed by 1 times 7. 11, 1 times 11. 97, 1 times 7. But other numbers can't be formed. For example, let's say 10. 10's got 1 and 10, but also 2 times 5, so it's not a prime number. So a prime number has only 2 factors, 1 in itself. And again, some of my students love this. They go, "Oh, that's really cool, sir. Can we keep trying to find higher and higher prime numbers?" But some of my other students say to me, "Oh, but sir, it's only for the exam. It's not really useful in the real world." And as a teacher, that's often the most challenging question you get asked. Someone putting their hand up at the back, and they'll be like, "What's the point of this?" And then, for prime numbers, I love it, because you can actually explain how in everyday life it impacts us day to day. So the top left, most of us should recognize, is WhatsApp. And the bottom right is credit cards. So whenever we send a message via email or we tap in a chip and pin, they get encrypted. And by encrypted means sort of like put in a secret code. And the way this is done is through prime numbers. So what they do is they get 2 prime numbers, 2 large prime numbers. Let's pick really small ones for now. Let's say 5 and 7. And they multiply together to give us 35. And that 35, that number there, is the code. So obviously, it's quite easy to work out what those 2 prime numbers are when we have really small numbers. So if we had, imagine the code was 21, we can work out that it's 3 and 7. They're both prime numbers. But if we start getting larger and larger and larger, it becomes really difficult. Without our sort of existing computing technology, prime numbers are almost uncrackable. So for now, prime numbers are like so significant to our modern economy. Without it, we wouldn't have technology safety. You couldn't go to the chip and pin machine. You couldn't send a WhatsApp message. I couldn't do an Instagram story. All these things that are sent as encrypted data really depend on encryption, and a lot of that depends on prime numbers. So let's say someone says, "Oh, but sir, I don't care about the real world. I don't care about this, it's man-made. We're creating these things, so it's not like a real thing. Then I'll say, oh, actually, if we look into nature, we can find prime numbers there as well, not just in sort of human constructs. So these little guys are called cicadas. So cicadas are almost what I say nature's mathematicians. So these are little insects. And I've never eaten them, but apparently they're quite tasty, good source of protein. So if you ever need something and you're sort of low on a protein shake or something, these guys are tasty. But these cicadas use prime numbers instinctively. And I don't know whether they've developed it. I guess I'm not an evolutionary biologist, but I'm guessing they've developed this over time and worked out that prime numbers really help their existence. I'll explain how this works. So cicadas come out and emerge every certain number of years. And I'll use algebra every X number of years. But because I said they've got lots of protein, they're really tasty, they have predators that come out every so often and say, ooh, cicadas are here, let's go and eat them, yum, 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 feed time. So cicadas have worked out that coming out every prime number of years actually means it's harder for their predators to catch them. So let's say a cicada comes out every 10 years, and 10 is not a prime number. So if there was a predator that came out every 2 years or 5 years, after, let's say if it came out every 5 years, 10 years, yum, 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 it would eat the cicadas. And if the cicada came out every 8 years, and let's say the predators came out every 2 years, 2 years, 4 years, 6 years, 8 years, yum, 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 eat the cicadas. So the cicadas have developed over time to come out in prime number years, 13 and 17. So when they come out in these patterns, if the predator comes, let's say I'm this angry predator, I come out every 2 years. I'm trying to catch the 13 one. 2, no, hungry this year. 4, still hungry. 6, still hungry. 8, 10, I'm really hungry. 12, 14, still hungry. Oh, I'm dead. I've been evolutionarily killed off. So predators find it really difficult to sort of coincide with the pattern of cicadas. And the reason I've got 13 and 17, cicadas are quite sort of smart between their species too. Because if they emerge at the same time, imagine there's one sort of cicadas, let's call them claret and blue cicadas, West Ham cicadas. Let's call another one Millwall cicadas. If they both came out every 13 years, there'd be fighting. Lots of fighting, sprawling, cicada chairs thrown, cicada beers thrown at each other, and that's not good. So what cicadas have worked out is actually, it works out well if they come in alternate prime number years as well. So if we had, let's say, West Ham cicadas come out every 13 years, and Millwall cicadas come every 17 years, they sort of occur at the same time every 221 years. And I guess we can deal with a fight every 221 years, but if it's every 2 or 4 or 6 years, it's not a good thing. So these cicadas are all across the eastern board of the United States. And the last time, I think the 17-year ones were in 2017. So if anyone's ever looking for me in 2024, you'll probably find me there in the east coast of America looking for these cicadas. And I probably will have to taste one too, because I've been told that they're tasty, but they only come out every 17 years, so that's going to be my opportunity in 2024. So these are things that I like. 4 things. So I think most of us should recognize, so on the bottom left, middle, we've got the Taj Mahal, really aesthetically beautiful building, built by the Shah Jahan for his wife. Then in the bottom left, we've got Da Vinci, Mona Lisa. Anyone seen it before in Louvre? Yeah, to be honest, I found it's amazing, but I found it quite underwhelming, quite a small picture. And actually next to it, there's a painting called the Raft of Medusa by Jericho, which I find actually even better. But anyway, it's universally acclaimed as a masterpiece. And then top left, in the middle, we've got J.K. Rowling's works, which sort of acknowledges some of the best children's literature of recent times. And in the middle right, we've got a rapper called Big Shaq. And in fact, he's how I got into maths. And my kids I can see my students are squirming. They know what I'm going to do. So he says 2 + 2 is 4, minus 1 is 3, quick maths. Everyday man's on the block. So a lot of students were singing this, and then they could recall all the lyrics of these, and yet, when it comes to a maths lesson, remembering Pythagoras' theorem or the trigonometric identities, they found that hard. So to me, it suggests it's not that mathematics is difficult, it's just that people are applying their minds elsewhere. But with these things here, so you may have different opinions on them, but generally, let's say the Mona Lisa, it's universally acknowledged as a world masterpiece. But if aliens came down today, they would look at the Taj Mahal and go, your buildings are weird, we walk upside down on the ceilings. They'd look at Mona Lisa and go, You humans, you've got 2 eyes. Oh my God, how ugly is that? Or they might read J.K. Rowling's work and go, this Hogwarts is all just pure nonsense. And then they go to Big Shack, and they'll say, I don't even understand what this guy is saying. So they wouldn't find that sort of appealing at all. But this is what I find fascinating. Mathematics is truly the universal language because they too would have the same prime numbers as us. 2, 3, 5, 7. Obviously, you have to take into account their number-based system. If any of you watch The Simpsons, they've got 4 fingers, so they would count in 8s. We've got 10, so we count in 10s, of course. So obviously, you've got to make a little adjustment for the number of fingers aliens have, whether they have 4 fingers or 17 fingers or 2,000 fingers. But once you've got that base system accounted for, they would still have the same prime numbers. And I find that amazing. Has anyone seen the film Arrival a couple of years ago? Yeah, fabulous film. So in this film, aliens come down, we're sort of a bit threatened by them, and the person they send up to negotiate is a linguist. But I'd like to think we should send up a mathematician, because the aliens, they would understand prime numbers the same as us. So I would send up a mathematician to negotiate with aliens, and I'll put my hand up, I'll be ready to take the hit and do the negotiations if anyone needed. So what I wanted to talk to you about is the connection between mathematics and love. And you might think, oh, I can't really find the connection. Maybe, in fact, it might be inversely correlated. The more you like mathematics, the less likely you are to find love. But I'll explain how mathematics can help you in that search. So there's a scientist called Drake, Francis Drake, in America. And in the 1960s, this is when people are really at the height of sort of like post-Roswell, really trying to find aliens around the world. And he came up with a sort of quantitative framework to try and predict the number of intelligent civilizations in a galaxy. So if I go through this, he said the number of intelligent civilizations is like a formula here. So the number of star formations per year, multiplied by the fraction of the stars, you need a planet obviously to live on. Then you multiply it by the number of planets that can support life. Then you multiply it by the number that develop life at some point. Then it's going to be intelligent life. So things like amoeba or insects are not particularly useful. So it's going to be intelligent life. Then you multiply it by the fraction that develops broadcastable technology. And then finally, the length of the civilization. And then from this, Drake was able to come up with a hypothesis, an estimate for the number of different civilizations. And he came up with 2 estimates, as low as 0.014. So that means we're probably not going to find anything. But if he's really optimistic and says that there's lots of stars being formed, the civilization's around for 10,000 years, we could have 140,000 alien civilizations in our galaxy, which means some of them may be amongst us now, which would explain some of the politics possibly. But it's a really good framework. So again, this isn't saying this is a definitive answer. And that's what I like about mathematics. It's about modeling situations, things in the real world. Because the real world we know is messy. It doesn't follow an Excel formula. You can't just tap in 7 times 7 is 49. We know the real world has complications. So mathematics can give us a framework to try and understand it. And from there, we can make sort of like adjustments to it. So what I've tried to do is use an adjusted version of this, which I've seen before, so I'm not going to take credit for this, but to try and work out, so I'm 34 now, is it a prime number? It's 17 times 2. In fact, kids often ask me what's my age in school, and I'll often tell them like a calculation saying I'm going to be a prime number in 3 years' time, and I was a prime number 3 years ago. And that's all I say to them. So if you're a student here, you didn't hear my age. So I use it to try and estimate how many potential people I could date. So I've covered the formula here. So what it does is, so G this time, instead of the number of intelligent civilizations, is the number of potential partners I could date. So what I've said is, it's the rate of formation of people in the UK, so the population. Then I said the fraction of people who are female is actually 0.506, but I'll be optimistic and say 0.51. Then the fraction of people females who live in London or Cambridge, because realistically, if I dated someone in Inverness or Dundee, it might not work, I know technology is quite good, but long distance is not my sort of thing. Then we look at some other factors. We look at age appropriateness. I know love holds no age, love sort of ascends all boundaries, but I said between 25 and 35, so I come up with a percentage there, 0.2 or 20%. Then the right age bracket. Then I put with a uni background, and this is one where people said, oh, Bobby, well, surely you should be more open than that. And this is more practical. Because I'm a teacher, most of the staff who I might meet have got a university background. And because I'm at Cambridge doing my research doctorate, I'm meeting people at university. So of course, if there are amazing people that support West Ham, listen to Big Shack music, and like watching Only Fools and Horses. I'm always open if you've not gone to university, but I'm just sort of using this for this calculation here. And then the last part of the calculation is people that I'm attracted to. So I said like, oh, 1 in 10, because I'm quite a short guy. So if someone's like 5'7", it's not really going to work. So I plug these in, and initially it gives me 29,000. I'm like, yes, 29,000 people, that's amazing, that's loads. But then I've done a couple of more adjustments to this. I've said, obviously they've got to be available. It's no good going to someone, hey, I'm Bobby Seagull, and I see a ring. It's over. So they're going to be available, so that's the half there. Then the 1 in 20 is they've got to find me interesting, etc. So I've been a bit pessimistic, but I said 1 in 20. But then I've also said to myself, once I found them, obviously I might go, actually only 1 in 10 of them are really the ones that I think that could do it. So with this, I've come up with, coincidentally, a prime number, 73 people out there that I would like to meet. And obviously this number could change because these people could emigrate, they could get married, they could get abducted by aliens. So I'm under a lot of pressure, especially for my mom. So my younger brother is 20, he's already married, 2 years, maybe children on the way, and I'm still waiting. So that 73 is currently the number as of publication date of my book. So the last thing I wanted to talk to you about is about mathematics and why it's such a beautiful language and it allows us to be precise. So on the top left, does anyone recognize this chap here on the top left? Yeah, cool, I'm glad to see a few. This guy's Matt Parker, and he did a campaign. So if you look at the road signs for footballs, you can see that they're all 6-sided hexagons. And there's a word called tessellation, which means you can sort of plant them next to each other on a flat surface. And hexagons tessellate on a flat surface and leave no gaps. But we know on a sphere, on a football, they don't tessellate. Otherwise, there'd be like a weird football with holes, and Ronaldo wouldn't be quite so good at football. But he said, yeah, actually on a football, we have pentagons with hexagons, and we know that they tessellate. So he actually did a campaign with government, and I think it was the most important thing last year politically, but got 100,000 signatures, but got turned down. So I'm still fuming. You know, people worry about Brexit and other things, but this is the thing that got me upset. Why did the government not accept changing the road signs? So my own campaign is going to be about the bike locks. And so I cycle around a lot in Cambridge. And these bicycle locks are called combination locks. So if your combination is 1, 2, 3, 4, you need the exact combination, as it were, to get to sort of uncrack your bicycle. But as a mathematician, I know that the word where the order matters is called a permutation. So if someone said 1, 2, 3, 4, and I put in 4, 3, 2, 1, it's not going to unlock the bike lock, is it? It's the wrong set of numbers. But it's called a combination lock, but in mathematics, the order does matter. So I'm starting a campaign. It's my first time publicly I'm saying it. So if you work at Argos or Halfords, seek me. We're going to try and re-educate the public. We're going to get these called permutation locks, because that's exactly what they are. So I've come back to this again. So for me, I know that not everyone in the country has had a positive experience in mathematics. You may have had a teacher that perhaps put you off, and it's not necessarily their fault, but you may not have got on with that teacher. You may have had experiences where you got lots of things wrong and you thought, I'm not a mathematician. You may have had friends putting you off. You may have had culture, society, all of those things. Actually, mathematics is not the right thing. And what I'm here to say today, and hopefully for the rest of my life, is that's fine. It doesn't matter where you start, but what we need to do is start being positive about mathematics. Talk about how mathematics can help us in our sort of looking at the world, the sort of space around us, whether we're cooking, everyone loves baking, mathematics is used there. Whether you're in the gym trying to work out the perfect routine, mathematics is used there. Whether you're like me, trying to find love at some stage, mathematics can help us there. So what I'd like to say, I think mathematics is magic. And I thank you all for coming here. And I'll be here, I think, later on signing books with my seagull-style signature. Thank you very much. I'm Bobby Seagull.